Okay, students, now let's proceed. We're coming to question number 3, and it is about writing the given matrix, a square matrix, as a sum of symmetric and skew-symmetric matrices. So you are given this matrix A. So let's see how we can write this matrix A as a sum of symmetric and skew-symmetric matrices. So the solution goes like this, students. Now, when you go to the solution part, we are having here the following. The matrix A is, as you see, a 3 by 3 matrix. So we know that our intention is to write matrix A as a sum of these two, symmetric and symmetric matrix. So we can write this A as half of A plus A transpose plus half of A minus A transpose. So if you multiple these two expressions by 1 over 2 and add, you will get A. So if you are able to use this, you are able to write the given matrix A as a sum of symmetric matrix and skew-symmetric matrix. So the thing here is, you see, to find the transpose of this matrix. So the matrix A is given as 1, 2, 3, 4, 5, 6, 7, 8, 9. I just read in a rows manner. So the transpose is going to be what has been taken as the first row is considered to be the first column, and the second row is considered to be second column, and third row third column, as it is labeled here. So a transpose is obtained. So now we need to determine the A plus A transpose. We have to determine A plus A transpose and A minus A transpose. Then we will take half of these two and try to take the sum. You see, the sum can make our given square matrix. So here we have matrix A is given, so as you see, it is labeled here, and the transpose of the matrix is also labeled here. So the sum of these two is going to be this one. As you see, every entry is added. You need to recall how you can add two matrices. So A plus A transpose is obtained. Now we need to determine A minus A transpose too, because as I said earlier, you see, matrix A is half of A plus A transpose plus half of A minus A transpose. Therefore, as you see here again, matrix A is directly taken and its transpose is also taken. Now we need to find the difference of each entries. So the difference of each entries, as you see, is again obtained. Now what comes next is, you see, what the half of the sum of the two. Half of the sum of the matrix A and its transpose. So when you take half of the sum of the two, already A plus A transpose is already determined. So take half of it. When you take half of that, it will be a matrix with entries 1, 3, 5, 3, 5, 7, and 5, 7, 1. So basically, students, this is a symmetric matrix because, as you know, a symmetric matrix is a matrix which actually is identical to its transpose. So this is basically a symmetric matrix because if you look for the transpose of this matrix, it's identical to itself, right? So this is a symmetric matrix, and again try to find half of the difference of A and A transpose, and you will obtain this to be this matrix, and this basically is skew-symmetric because as you see, a skew-symmetric matrix is not, but it is a negative of its transpose. So if you look for a transpose of this one and find its negative multiplier, you will obtain this. So this is a skew-symmetric matrix. Even the diagonal entries are all 0, as you see. So look, we obtained these two. So the next task is a matter of adding the last two matrices obtained. So if you take the sum of the last two matrices, you will obtain matrix A. So in such a way, whatever square matrix is given, we can write that matrix as a sum of symmetric and skew-symmetric matrices. I hope you have understood it. Now what comes next is the next question number 4. Here in question number 4, you are given a matrix A having k number of rows and k plus 5 number of columns, and a matrix C having t number of rows and minus t plus 11 number of columns. So you are asked to find the values of k and t such that the product AC and C times A, product of these two matrices, can exist. Basically, in order to do this, what you need to recall is the property of product of two matrices, students. In order to carry out product of two matrices, or in order to define product of two matrices, for example, A times C, matrix A times matrix C, the number of columns in matrix A must match with the number of rows in matrix C, that is in the second matrix. So, using this property, the number of rows in column A, as it has been stated, is k plus 5, And the number of rows in the second matrix, that's matrix C, is T, as it has been stated. So we do have one equation now with two unknowns, K plus 5 is equal to T. Now what comes next is, again, for this product C times A to exist again, the number of columns in matrix C must agree with the number of rows in matrix A. So if this is so, minus T plus 11, which actually was the number of columns in C, must match with, or must be equal to, the number of rows in matrix A, which actually is K, as it has been stated. Now, dear students, we have got two equations with two unknowns, so we can now solve these two simultaneously, okay? So we can use direct substitution method here. It has been said that K plus 5 is T, so in place of K, one can put minus T plus 11, because minus T plus 11 is the same as K. So minus T plus 11 plus 5 is equal to T can come. And now look, everything is written in terms of T. So if everything is written in terms of T, look, you can move this minus T to the right, and 2T equals 16 can come. And from this T is going to be 8, and in order to know what K is going to be, you can use K as minus T plus 11. I just have used the lower one. You can also use the upper expression. So put minus 8 in place of T, and then you do have K value to be 3. So the K and T values are obtained. I hope you have understood. Now comes question number 5, and in the case of this, you are having two matrices, M and N, as you see. M is a matrix of size 3 by 2, and N is a matrix of size 3 by 3. So if D is another matrix obtained by transposing M and multiplying with N and with entries, D23 9, D13 65, and D11 30, you are asked to find the value of B. So how can you find that? Simple. So what you need to do is the following, students. M is this one, so transpose of this is going to be this one. You see, you simply interchange rows to columns, okay, or columns to rows. So your transpose comes like this. Now what comes next is, you see, we need to multiply the transpose of M with N in order to determine what D is going to be. So the transpose is already done, as you see, and now you just copy and paste what matrix N is going to be. Now you need to multiply this, as I explained earlier, or as we did in the classroom. What we need to do is we have to now multiply what, students? These first row entries with first column entries, okay? So that makes D11. D11 is an element obtained at the intersection of the first row and the first column, okay? And here we do have a D12, and this is basically is obtained by taking the linear combination of the first row of the first matrix and the second column of, you see, the second matrix. As you are doing that, you will obtain this D1, 2, and 3. You do the same for the rest according to the way you see everything is labeled here. So finally the output of this is going to be like this, as you see. So you have been told that D23 is 9. This shows that the element at the intersection of second row and third column. Which one is that, students? The second row and third column is this one, student. This one should be the same as what, 9, but this needs to be simplified further. Anyway, you will obtain this one as a final output. Now look here, D23 must be 9. D23 is what, student? The second row, the entry obtained at the intersection of the second row and the third column, and that is 3p minus 6. This 3p minus 6 must be the same as 9. So from this, one can easily determine what the value of p is going to be, okay? So p comes 5, as you see. Look, because 3p minus 6 needs to be 9, and moving minus 6 to the right, 15 can come, and divided by 3, 5 can follow, okay? So the value of p is 5, so p is already determined. Even though p is determined, our interest is to find the value of b, but let you use another given condition. You have been told again that D13 is 65, so D13 is the element obtained at the intersection of the first row and third column. So the first row is this one, and third column is this. So for Q plus 57 needs to be 65. So from this, the value of Q can now be determined. Now it is 2, because 4Q plus 57 is equal to 65 implies that Q needs to be what, 2, because we are going to have 4Q being equal to 8, and from that Q needs to be 2. Now look, students, D11 is also specified. D11 is the element obtained at the intersection of the first row and the first column, and that is BQ plus 60. BQ plus 60 needs to be what, students? 30, as it has been stated. But we knew what Q is. Q is already determined, it is 2, so have that Q value here, then B times 2 plus 60 equals 30 can follow. And from this, the value of B can easily be known. It's a matter of moving 30 to 60 to the right, minus 30. So dividing by 2, you'll have B to be minus 15. I hope you have understood the way how I have done every step.